Hi, good evening. Okay, so there are 4 students in class. May I know your name, guys? Okay, then? Okay. Okay, then who is it? Okay, dear, thank you. Okay, let's get started today's class. So today we are going to see triangles. Okay. Okay. Have you learned already about triangles? Yes. Okay. Okay. So today we are going to learn about congruency of triangles. Okay. What do you mean by congruency? Yes. Anybody? See, guys, feel free. My name is Neeta. I hope you know my name. Yes. I know Tamil. Okay. I'll speak in English. See, if you don't feel comfortable, whatever, if you don't get it, you can ask me. Feel free with me. If I'm teaching something, if you don't understand, please ask me again and again. I'm there to help you. Okay. நான் சொல்லித்தரேன் ஏதாவது புரியலன்னா நீங்க ஃப்ரீயா கேட்கலாம் இது புரியல இது புரியுது சரியா okay okay then so okay tell me guys what do you mean by congruency தெரியல okay congruency it means if you or figure இருக்கு if you fix one over the other figure it exactly fix one over other then that kind of figures are called congruent figures practical example சொல்லணும்னா for example two 5 rupee coin if you take two 5 rupee coins if you fix one over other exactly it fixes amava yes so this is called congruency இதே வந்து if you take one 1 rupee coin one 5 rupee coin will it fix if you keep one over other will it fix exactly one over other no இல்லையா because both are circle but the sizes are different isn't it they are similar both are circle though the sizes are different that kind of figures are similar if two figures are alike their side everything is exactly same then they are called congruent I'll show you in drawing okay I'll be sharing my screen I hope you guys can see my screen isn't it okay fine okay so there are two circles if you see these two are circles but they are different in size these kind of figures are called similar that you will be studying in 10th standard okay similar figures okay but if you see these two figures these two are exactly look alike isn't it the measure size everything so these kind of figures are called congruent okay so this is it means congruent if two squares are congruent and the side measures are equal you can easily say two squares are congruent two circles are congruent if radiuses are equal they are congruent but in case of triangle we can't fix it isn't it so we have certain criteria to say whether the given two triangles are congruent or not how do we see what are the criteria we will see one by one okay so today's topic is triangles in the under triangles subtopic is congruency okay write a title put a date write the title triangle under that congruent okay see there are certain criteria are there we will see one by one criteria okay first criteria is yes 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 that means there are two triangles are there ABC PQR then the measure of AB is equal to PQ. The measure of AC is equal to PR. The measure of BC is equal to QR. Then you can say by SSS criteria, triangle ABC is congruent to triangle PQR. One thing you should make a note of it. See, triangle A, the angle A is matching with angle P. And angle B is matching with angle Q. And angle C is matching with angle R. So that way you're supposed to write. That order is very, very important. You can write ABC, triangle BCA, any way you can represent. But when you say two triangles are congruent, the order, the way we are writing is very, very, very important. So if you see this one, A is matching with angle P, B is matching with angle Q, angle C is matching with angle R. This is the way you have to say two triangles are congruent. Next, next congruency is SAS. SAS means side angle side. Okay, so if there are two triangles, again I take ABC and PQR side. Okay, this side is matching with this side, this angle is matching with this angle, then this side is matching with this. Then you can say by SAS, triangle ABC is congruent to triangle PQR. One thing you make sure, the angle must be between those two sides. Okay, otherwise it is not counted. Okay, then the third one, ASA, that is angle side angle. That means angle side angle. Okay, so by angle side angle, so angle, that side must be inclusive of these two angles. Okay, that is ASA congruency. Then AAS, angle angle side. That means there are two triangles. Angle side. See, A is matching with the P, angle B is matching with the Q, and the side measure B is matching with QR. Then by AAS, triangle ABC is congruent to triangle PQR. Okay. Then the last criteria is RHS. This is applicable only in right angle triangles. What is right angle triangle? Yes, anybody? Very good, super. One of the angle must be 90 degree, then two triangle, the triangle is said to be a right angle triangle, isn't it? Okay, we consider two right angle triangles, A, B, C, P, Q, R. So right angle, hypotenuse. What do you mean by hypotenuse? Opposite to, see, two ways you can say, opposite to 90 degree. The side which is opposite to 90 degree, it is hypotenuse, or the greatest measure, the greatest side in a right angle triangle. Either way you can give. Okay, hypotenuse and side, any side, it can be any one of the side. Okay, the side. Then by RHS, triangle ABC is congruent to triangle PQR. Okay, make a note of, see, you have to remember all the 5 criteria. Okay, SSS, SAS, ASA, AAS, or HS. So if you want to prove any two triangles are congruent, you must prove by any one of the criteria. Okay, make a note of it. We will do sums on this concept. Yes, have you copied? If copied, just raise your hand, okay? Okay, guys, have you copied? Okay, okay, fine, fine. Okay, dear. So what is given? The median. Okay. What is an equilateral triangle? Very good. If three sides of a triangle are equal, then we say equilateral triangle. Any other property of an equilateral triangle? Can you tell me? Yes. What is the measure of three angles?
90 degrees.
Huh? How much angle? How much degree is that? Each measure equals 60 degree. Isn't it? Each angle. What is angle sum property of a triangle? Very good, very good. Okay. Now, so you have to prove that medians of a equilateral triangle are equal. What do you mean by median? Anybody, anyone? Okay, I'll tell you. Median is a line which joins one vertex to the opposite side midpoint. Okay, if I name the vertices as A, B, C, and this is, I name it as D, the median is a line. AD is called median as one, it will join one vertex to the opposite side midpoint. So that BD must be equal to DC. Okay, so in a triangle, how many medians can be drawn?
2 medians.
Why 2 medians? There are 3 vertices. So you could draw, yes, 3 medians can be drawn. This is one median. Okay, E, and I use this one. I name it as F. So you can draw 3 medians. In this, AD,
AD, F, C, E.
BE, and CF or medians. Okay, now we want to prove medians of equilateral triangle are equal to prove AD equals BF equals CF. How come? Okay, we will do one by one. First, I'll take only one median. Okay, consider one median. ABC. And I draw a median. This is D. We know that these measures are equal, isn't it? In an equilateral triangle. So given, what is given? In triangle ABC, AB is equal to BC is equal to AC. The reason is it is an equilateral triangle, isn't it? Equilateral triangle. Okay. Now, and okay. Okay. So this is an idea. We don't want to prove it. Okay. We will keep a okay. See, any triangle, any two medians, I draw another also. You take another triangle, another median, and E. If you see, yeah, in that, if you take the portion, how do we prove it? Wait, once again. Okay, if you consider this triangle, in triangle A, B, D, and triangle this one, A, B, E, A, B, E, this triangle, these two triangles I am considering. Okay, A, B, E. Now, if you check, AB is equal to, in both the triangles, AB is equal to AB, side measures, isn't it? They are equal, correct? See, this side measures are equal. And what else? And the angle A is equal. Angle A, both the cases, angle A is equal. That is equal to 60 degree. Then what else? You know that BC is equal to AC because it is equilateral triangle. So half of BC, half of divided by 2, half of BC divided by half of AC, then what happens? Half of BC, you can write BD, isn't it? Guys, see, BC is this, half of BC is BD. You can write BD. Similarly, AC is this, half of AC is AE, isn't it? So, what you can write by yes, A, yes. SA is criteria. You can say these two triangles are congruent. For your comfort, I draw separately. You will have a better understanding. Okay. Wait, I'll draw it. You may get confused, so I'll draw it separately. A, B, D, and another triangle. It will be like this. Okay. Okay, this is A, B, E. Okay, now if you see, I think this doesn't come, I guess. Okay, wait, this one I made mistake. Okay. Okay, now if you see, A is matching, both the AB are common, it's matching, and BD is equal to AE, and this angle is 60 degrees, isn't it? This angle is 60 degree, but here this is 60 degree, isn't it? This is 60 degree. Okay, by side angle side. Okay, but by side angle, side, you can write triangle ABD. The way you write it matters. Okay, ABD is congruent to triangle what? ABD. A is matching with, okay, this here, it will be, okay. Now, wait, I'll show you how to write it. The corresponding side, that way you have to mention the triangle. Okay, so this must be matching with this, and this must be matching with this. Okay, now the way, so the angle A is matching with B. So BAE. Okay, this way you have to write. If two triangles are congruent, this way you have to write. Angle ABD is equal to angle BAE. These two triangles are congruent. By CPCT, what is CPCT? Anybody? Have you heard the word CPCT? No? Okay. Congruent, corresponding parts of congruent triangles. Okay. So CPCT means corresponding parts of congruent triangles. That is CPCT. Okay, you have to make a note of it. I'll tell you. See, so you can say BD, the median BD is equal to, not AD, I'm sorry, AD is the median. Okay. Yeah. AD is equal to BE. Okay, hence proved. One thing you should know, if two triangles are congruent, all the three angles, corresponding angles are equal, corresponding side measures are equal. So according to this, these two triangles are congruent. So what is left? These two measures are equal. Obviously, this measure, this AD must be equal to what? BE. Okay, that you should not make a note of it. If we do 2, 3 sums, you will be fine. Okay, that's it. So from this sum, what you learned, in an equilateral triangle, the medians are equal in length. That's it. Okay, that concept you should know.
Yes,
Okay. Guys, have you copied? Okay, dear. Okay. Okay, fine. Next. Okay. This is another theorem. the angles opposite to two equal sides of a triangle are equal. That how do we prove it? Okay. So what is given? You have to write proper given. That is very, very important. What is given? There is a triangle. Let ABC be the triangle. Be the given triangle. In that the angles opposite to two equal sides. In the sum itself, it is given two sides of the given triangle or equal. Let AB is equal to AC. It is given in the sum itself. AB is equal to BC. Yes. So what you want to prove? The angles opposite to the equal sides are equal. So you want to prove it. You want to prove it equals. The angles opposite to equal sides are equal. So to prove angle B is equal to angle C. How come? Again, we are going to use congruency concept. What I do, I draw a median through vertex A. Okay. Let AD be the median. Solution. Draw. So what are the new things we are introducing? We supposed to mention it. So that is nothing is given in the figure or nothing. So we are drawing AD. So you're supposed to mention draw AD a median. Okay, then so which implies the symbol. So what does it mean? BD is equal to CD, isn't it? These two measures are equal because the median is a line which joins one vertex to the opposite midpoint, isn't it? Okay, now what we are doing, we are considering these two triangles. You're supposed to mention what triangle we are considering. Okay, so you have to write this way. In triangle ABD and triangle ACD. So these are the two triangles we are considering. We start from the known concept. We know that AB is equal to AB is equal to AC. It is given in the sum. And BD is equal to CD because AD is median, isn't it? AD is median. So we know. Then what about AD? AD is common to both the triangles, isn't it? AD is common. AD is common. So here these two sides are matching in both the triangles. When you consider two triangles, AB is matching with AC, BD is matching with CD, AD is common. By what criteria you could say these two triangles are congruent? Tell me. Let's see who can say. Check with the criteria and tell me. The list of criteria I have given already, right? See the criteria and tell me.
Yes.
See, this one you want to prove it. We don't know. Angle B is equal to C. We don't know. We have to prove it. What I'm saying AB is equal to AC. In this triangle, huh?
Yes.
I don't think so. No. See, dear, listen. So I'm considering two triangles, ABD and ACD. So in this, I'm saying AB is equal to AC and BD is equal to CD and AD is common. So what criteria you could say in these two steps? What I'm saying, three sides of the triangles are equal to three sides of the triangle. Then what criteria you could use? See the criteria. Tell me list of the criteria. Huh? Tell me what are the criteria you have? List the criteria. No, wrong again. It is not right angle triangle. Who said it is a right angle triangle? See, tell me, list the criteria. What are the criteria you know? First criteria is what? See the notebook. You already copied, right? Huh? What is first criteria? Yes, yes, yes. Side, side, side. Isn't it? Such a criteria is there or not? Yes. So by yes, yes, yes. Yes. So by yes, yes, yes. Side, side, side. By side. Because I'm saying this side is matching with this side. Okay. See, I'm saying what I'm saying. You should see this side of the triangle is matching with this side. Okay. I don't want to scribble. Okay. Okay. AB is matching with AC. BD is matching with CD. AD is common. So two triangles of equal side measures. So you can say by SSS, triangle ABD is congruent to triangle ACD. So you could say what? By CPCT, CT, angle B is equal to angle C. Hence proved. That's it. Okay, guys. See, one thing you should know, if I'm saying two triangles are congruent, angle A is matching with angle A, angle B is matching with angle C, angle D is matching with angle D. And one more thing you should know, the side measures. From this itself, you can write. Okay, AB is equal to AC and BD is equal to CD is equal to CD and AD. AD is equal to AD again. AD is equal to AD. So from this, sorry, what happened? Voice is cracking. Oh, is that so? Now is it fine? Can you hear me? I don't know what's the problem.
Yes,
Okay, okay. Thank you, guys. Make a note of it.
yes, ma'am.
Guys, if you copied, let me know.
I'm finished, ma'am.
Okay, good. Okay. Okay. So next sum is, listen, next sum what is given? Prove that triangle ABD is congruent to triangle ACD. Given. So these are given. So first you have to draw the figure for the question. First you draw ABD, triangle ABD. But if you see ACD, AD is there, C somewhere it seems. So it is attached. Both the triangles are attached, it seems. So we draw that way. Okay, so VCD. Okay, then what else is given? BD is equal to CD. Okay, and BD equal to CD, that is 5 centimeter. And ADB equals ADC. ADB, this angle. ADB is equal to ADC. It is given. Okay. Now we want to prove these two triangles are congruent. How do? Okay. Solution. So always one thing you should remember. What are the two triangles? Your first step is, what are the two triangles you are considering? You are considering the two triangles in triangle ABD, and we don't know they are congruent or not. We don't know. We are taking the triangles. Triangle ACD. Okay. This is first step you should write. Then second, what is given? It is given in the sum that BD is equal to CD. It is given in the sum, isn't it? It is given in the sum. And angle ADB is equal to angle ADC. That is also given in the sum. Okay. Then what else you can say? What else? What about AD? The side AD? Anybody? The side AD is common to both the triangles, isn't it? Yes. AD is common. Okay. Now, anybody can say, let's see who can say correctly. By what criteria these two triangles are congruent? Yes? See, guys, one thing clear. RHS is only applicable to right angle triangles. In this, which one is right angle here? They are not right angle triangles. How come you use that criteria? That's very good. SAS, because side, angle, side, isn't it? For this also side, angle, side. Very good. By SAS criteria, triangle ABD is congruent to triangle ACD. That's it. Hence proved. Very good, guys. Make a note of it. Now you understood, right? How to prove two triangles are congruent. That's it. Good. Okay. Okay, now you see the sum in the figure. So the figure is given. O is the midpoint of AB. O is the midpoint of AB. So AO is equal to, so this symbol denotes the measures OA and OB are equal. And prove that AC is equal to BD. You have to prove AC is equal to BD, and it is given. You have to prove both AC is equal to BD and AC is parallel to BD. Both the things you have to prove. So what you have to prove?
AC.
AC equal to BD and
AC parallel to
BD. Okay, now let's see the solution. So first step, what did I say? You have to take the triangles. Okay, the order. So I'm writing AOC. I'm taking the triangle AOC and triangle BOD. Okay. Yes, BOD. These are the triangles. I'm considering that. What I know, from that I start. So it is given that OA is equal to OB and OC. See, this symbol denotes they are equal. This symbol denotes they are equal. Okay. So it is given O is a midpoint of AB and CD. So OA must be OB and OC must be equal to OD. Okay, so that is equal to OD. It is given in the sum, or O is a midpoint. O is a midpoint of AB and CD. You can write this way. Okay. Then what about these two angles? What kind of angles are they? I marked some angle in the figure, right? What kind of angles are they? No, dear, I'm not asking about, I'm not coming to that point itself. I'm asking simply two lines are intersecting. If two lines are intersecting, what about these two angles? That is what I'm asking. Okay, have you heard the word vertically opposite angles? Yes, vertically opposite angles are equal, isn't it? Yes, vertically opposite angles. Okay, so here, so these two angles are equal. The reason is they are vertically opposite. So you can write that way. Angle AOC is equal to angle BOD. Why? Why you have to write the reason? Because they are vertically opposite angles. Okay, now tell me by what criteria you could say these two triangles are congruent?
Yes.
Very good, very good. By ASA. How come ASA? No, I don't. SAS. Side angle side. Side angle side. Triangle AOC is congruent to triangle BOC. Isn't it? So by, you can write by CPCT. What you can say by CPCT, obviously the third side must be equal to this side, isn't it?
Yes, ma'am.
Yes, AC is equal to yes, AC is equal to BD, hence proved. So we proved this. Okay, then we had to prove this. How come? How come? I told you if two triangles are congruent, the corresponding angles are also equal. So this angle must be equal to this. And I told you, no, this angle must be equal to this, and O must be equal to O, and C must be equal to C. See, this is D. I'm sorry, I made mistake. This is D, isn't it? So this angle must be equal to this angle. Okay, now see the figure and tell me if these two angles are equal. This is a line. See, these two are lines, and this is a line. Okay, then if these two angles, what kind of angles are they? I'm saying, okay, tell me these two lines are parallel. Okay, L1, L2 are parallel. Then what kind of line, what kind of angles are they? They are equal. Name the angles. Okay, I say, I told already line 1 and line 2 are parallel to each other. They are parallel. And what about L3, the line L3? What is the name of that kind of line?
Transversal.
Very good, very good. Transversal line. Very good. You're right. Okay, now name this angle. These angles are equal, isn't it? Okay, what is the name? See, you told, right? These two angles are vertically opposite angles, and vertically opposite angles are equal, isn't it? Same way, you tell me, what is the name of this angle? Superb, dear. Superb. Yes, exactly. These two angles are alternate angles. Alternate angles are equal. So now you come to this figure. If you see, it is given these two angles are equal. Then this must be a parallel lines, right? These two lines must be parallel. Then only these two lines must be equal, isn't it? Got it, guys? This AB works like a transversal line. So you can say, this step you can write. For the second sum, angle OAC is equal to angle OBD. OBD alternate. So which implies AC must be parallel to BD. Hence proved. You can write in the bracket alternate angles. Yes. Make a note of it. Okay, guys. See, this kind of sums, you have to understand the concept. You have to write in your own way. Okay, don't mug up it from the book. Okay. Guys, feel free with me. Can you understand the way I'm teaching my slang? Everything is fine? Are you feeling comfortable? Okay, that's good. Okay. See, always write the sum and copy the solution. Otherwise, you don't understand what for what you have write that solution. Okay. This one, read the figure.
The figure AB parallel AD and BC intersect both. The O is a point of A. Show that triangle A would be equal to triangle DOC and OB equal to.
Okay. Okay. Now, okay. Now, what are the two triangles to be considered? Yes, tell me. COD, triangle COD and
AOB.
better you see is the same way you say, see, COD. If you take COD, if you take COD means you take BOA, that would be better. Okay. Triangle BOA. BOA. Okay. Now tell me what are given in the sum. So it is given midpoint. So OD is equal to OA, isn't it? OD is equal to OA and angle COD is equal to angle BOD. Why? Why the angles are equal? The previous sum we have seen. Vertically opposite angles. Okay. Now see, it is given in the sum CD is parallel to AB, isn't it? So what about these two angles? Alternate angles. Very good. So you can write angle CDO is equal to angle BAO. BAO. The reason is CD is parallel to AB, isn't it? Or they are alternate, whatever. So, but by what criteria these two triangles are congruent? Somebody said, tell me.
Ma'am, ASA.
Superb. Very good. ASA. Angle, side, angle. Very good. By ASA, triangle AOB is congruent to triangle DOC. Hence proved. Okay. Then how do you write OB is equal to OC? Simply you write by CPCT. Just write CPCT. CPCT, OB is equal to OC. That's it. The sum is over. Okay, guys, make a note of it. Okay. Okay. A quadrilateral ABCD. Yes, guys, tell me, what do you mean by quadrilateral?
Quadrilateral means opposite.
No.
Ma'am, quadrilateral means four sides are equal.
No, four sides are not equal. See, quadrilateral means it's a four-sided figure. That's it. Square is a quadrilateral. Rectangle is a quadrilateral. Name some quadrilaterals. Any quadrilaterals, whatever quadrilaterals you know, tell me. List the square. Then rhombus. Then yes, trapezium. Trapezium is a quadrilateral. Then parallelogram. Parallelogram is a quadrilateral. Kite is a quadrilateral, isn't it? Any four-sided figure is a quadrilateral. That's it. Okay. Okay. So here it is given ABCD is a quadrilateral. AB is parallel to CD. AB is parallel to CD. So this is a symbol. The arrow mark denotes the lines are parallel. And BC is parallel to AD. BC is parallel to AD. It is given. Show that triangle ABD is congruent to triangle CDB. Okay, let's get started. Okay, solution. So what are the triangles considered? These are the two triangles to be considered. These are the two triangles. So I'm taking the two triangles, triangle ABD and triangle CDB. Okay, now tell me. Okay, from the figure, as AD is parallel to BC, what about these two angles? Alternate angles, correct. Okay, what alternate angles are equal, isn't it? Okay, What about these two angles? Again, alternate angles. These two angles are equal because they are alternate angles and these two angles are equal. So you write that way. Okay. Now you write angle ABD. Angle ABD is equal to what? Angle ABD is equal to what? Which angle? CDB, isn't it? Yeah, CDB. Why? Why? Alternate angles. Then similarly, angle ADB. ADB. Sorry. ADB. Again, I'm mistaken. Yeah, ADB is equal to angle CBD. CBD. The reason again, they are alternate angles, isn't it? Okay, tell me. And what about BD? BD is common. For both the triangles, BD is common. Isn't it? BD is common. Then, by what criteria they are congruent? Very good. Angle side angle. By ASA, triangle ABD is congruent to triangle CDB. Okay, then by CPCT, you simply write the rest. By CPCT, you can write AB is equal to CD and AD is equal to CB. Hence proved. That's it. Guys? Okay, make a note of it. Okay, fine. Actually, time is up. We just discuss, okay? We just discuss the sum. Read the sum and tell me what is the idea. How do you prove these two triangles are congruent? Yes.
In figure, AB equal to CD and ABC equal to angle BQD and then angle BAC equal to angle QBD. Prove that angle ABC common ABQD. Yes, ma'am.
What's the idea? How do you prove these two triangles are congruent? No, you should not say that way. No. See, AB is equal to, it is given, and these two angles are equal. Okay. But it doesn't seem the B and the C are midpoints. Nothing is given in such way, isn't it? Okay. Okay, see dear, I'll tell you how to prove it. We will wind up with this session. I'll complete this one. Okay, so we are considering the triangle solution I'm writing. So what are the triangles to be considered? Triangle APC and triangle BQD. isn't it? So in the sum itself, it is given angle. I write straight away. I write P is equal to angle Q. It is given in the sum, isn't it? Similarly, angle A is equal to angle B. That is also given in the sum. It is given in the sum, isn't it? Then AB is equal to CD. It is also given in the sum, isn't it? AB is equal to CD. This measure is equal to this measure. Isn't it? It is given in the sum. Okay. So it is given in the sum. I add CB either side. I add CB. CB, what happens? AB plus CB is what? AB plus CB is what? AC, isn't it? AC. So this becomes AC. Similarly, CD plus BC is what?
CD plus DB.
DB. DB or BD, whatever it is, DB. Okay. So which implies by what criteria you could say? These two are congruent. This is first step, 1. This is 2. Okay. This is 3. From 1 to 3, what you could say? Yes, very good. Who said that? Very good. Yes. Okay. From 1, 2, and 3 by angle, side, isn't it? Angle, side by AAS, triangle, what? APC is congruent to triangle BQD. Okay, that's it. Hence proved. Make a note of it. Time is up, guys. See, one thing you remember, try doing the rest of the sums. Okay, you try on your own way. Don't see the solution in the book. And mark if any sum you can't prove it. You mark, and when come to next class, you tell me, we will discuss that sum in the class. Okay, guys? Okay, dear. Make a note of the sum, and that's it. Yeah. Okay, see then. Bye-bye, guys. Bye. Okay, do try the rest of the sums. Okay? Okay. Bye.